In the previous meeting, I have discussed matter and its classification. Now today, I am going to discuss characteristics of particles of matter. Let us perform an activity to decide about the nature of matter. Is it continuous or particulate? And I am going to perform one activity in front of you people. So I am taking this glass of water. I am taking this glass of water and I have marked the level. And in this glass of water, what I am going to do? I am going to dissolve 1 spoon of sugar to it. So I am going to dissolve 1 spoon of sugar to it. This activity you can perform yourself because sugar is easily available, water is easily available. So you can perform this activity and then this activity becomes more clear to you. Now what happens when I put a spoon of sugar in water? Then what happens? The sugar gets dissolved in water and I have marked the level over here, but the level of water does not increase. So what does it mean? Where these sugar particles are going. So where these sugar particles are going? So it means the sugar particles are going in between the spaces which are present between the particles of the matter. And these particles of matter, as I have told you earlier, they are very small in size. Now in order to explain how small are these particles of matter, I am going to perform another activity to you in front of you. Here I am taking few crystals of potassium permanganate and 1 or 2 crystals. Now can you see? Now when I add the crystals, you can able to see the movement. Can you see the movement? The potassium permanganate crystals, they get dissolved. It means you can easily see, it means there are the spaces. They are moving. The particle, when in this glass of water, you are not able to see the movement of the particle. But when I have added few crystals of potassium permanganate, then what you observe? You observe the movement. So what I will do? I am going to stir it well. On stirring, the purple color is obtained. On stirring, what has happened? Purple color is obtained. And I am going to take few drops of this purple color into this. Now you can able to see and stir it well. Now again the color is there and this color is light. Now then again what I am going to do, I am taking a little bit of this solution here. So you will see color is still there but a fade color. And if I add, the color is still there. So from this experiment, what this experiment shows? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. Ultimately, a stage is reached when the particles cannot divide into the smaller particle. Now, I think that in your house, Dettol is easily available and you can perform this activity with Dettol also. Okay? And from this experiment, with the help of this experiment, what I want to show? I want to show that the particles of matter are very, very small. Now, come to the characteristics of the particles of the matter. Now, what are the characteristics of the particles of the matter? The first property is matter is made up of many small particles. Matter is made up of many small particles, and these particles are atoms or molecules. These particles are very, very small, and with the help of the first experiment that I have performed in front of you, it is clear that these particles have spaces between them. These particles have spaces between them, and these particles are continuously moving. And in order to prove that how the particles of matter are continuously moving, you have to perform one activity yourself. What you have to do? Incense stick or dhoop. It is available in all the houses. Now light that incense stick or the dhoop and observe it. What you observe, and in the next class I am going to ask you. Okay? So these particles attract each other. So with the help of these activities, we have written the characteristics of the particles of matter. Now, this property, the particles of matter attract each other. The particles of matter attract each other. As you know that there are 3 states of matter. 3 states of matter are solid, liquid, and a gas. Now these particles attract each other. This is a pen, and if I want to insert my finger inside this pen, so I am unable to do it. This is the glass of water, and if I want to move this pencil in the glass of water, I can move. And if I want to move my hand here, as you know that air is present everywhere, so I can move my hand easily. Now what you conclude? So I am going to draw the structure of the solids. So in the solids, the particles are tightly packed. In solids, particles are tightly packed. So when these particles are tightly packed, so they have strong force of attraction. And this strong force of attraction between the particle, it does not allow the particle to leave their space. And because of this strong force of attraction, this has a definite shape. So there are no these are the spaces these spaces are known as the intermolecular spaces. So in the solid state, intermolecular spaces are negligible, and the force of attraction is the very, very strong. And because of this strong force of attraction, the particles do not move from one place to another, but they only vibrate about their mean position. And if I talk about the liquid, in the liquid state, this is water. Water is the liquid state of matter. This is the liquid state of matter. And in the case of water, the arrangement of particle is like this. And when we put, suppose when I put sugar into it, so sugar gets accommodated in between the spaces. So these are the particles of the liquid. Now, force of attraction between the particles is less than the solid, and this liquid has the intermolecular. I am going to mark the spaces. These are the intermolecular spaces. With the pencil, I am going to mark the spaces, and these spaces are known as the intermolecular spaces. So I can easily put pencil inside it, and where this pencil is going? This pencil is going into the water. So this shows that there are a lot of spaces which are present in water, and because of these spaces, I can also move my finger. You can easily cut a stream of water. All of you, I have seen you playing with water. All of you cut the stream of water with your finger. So it means the force of, but you are not able to take that stream of water along with you because the force of attraction is there, and the force of attraction does not allow the particles to leave their place, but the particles can move from their position. Third stage is the gaseous state, and in the gaseous states, the particles are far away from each other. They are far away from each other. If this particle wants to move here, it can move. If particle wants to move there, it can also move here, there. So there is no force of attraction between the particles. Force of attraction is negligible. Force of attraction is negligible, and intermolecular spaces are there. So force of attraction is negligible and the intermolecular spaces are there. Now I am giving you one activity. What you have to do? You have to take any three things. I think nail is easily available, chalk, if chalk is available, or the rubber band, I think it is available. Now what you have to do? Try breaking them by hammering or by cutting or by stretching. And in which of the 2 or 3 substances do you think that the particles are held together with a greater force? So the activities which I performed today is, these activities explains the characteristics of the particles of the matter. So in the next class, we will be studying about the various states of matters in detail, and in that class I am going to discuss the properties of the 3 states of matter.